Lewis structure. Lewis structure is the structure in which we show bonds between atoms and lone pairs electrons. To draw the Lewis structure of a compound, we follow these steps. First step is to calculate the total number of valence electrons of atoms in a compound, and the second step is to select the central atom with lowest electronegativity, and the final step is to draw the skeleton structure in which we connect the remaining atoms to the central atom through single bonds in a compound. Let me take one example here, phosphoric acid, and its chemical formula is H3PO4. To draw the Lewis structure of this compound, we follow these steps. First step is to calculate the total number of valence electrons. Well, hydrogen has one valence electron, and there are 3 hydrogen atoms in this compound. That is why we multiply by 3, and here 3 hydrogen atoms have 3 valence electrons. Next atom is phosphorus. Phosphorus atom is present in 5th group, and the number of group represents the number of valence electrons in an atom. That is why phosphorus has 5 valence electrons. Next atom is oxygen. Oxygen is present in 6th group, and that's why it has 6 valence electrons. Since there are 4 oxygen atoms in this compound, we multiply by 4, and 6 4s are 24. Here 4 oxygen atoms have 24 valence electrons. Now we add these numbers up. 5 plus 3 is equal to 8, and 8 plus 24 is equal to 32. The total number of valence electrons present in phosphoric acid are 32. Now we follow the second step, that is to select the central atom. Central atom is selected that atom which has lowest electronegativity except hydrogen. Hydrogen is never considered as a central atom because hydrogen has one valence electron, and that's why it cannot form more than one bonds. And despite the fact it being the lowest electronegative atom, it is not considered as the central atom. Now we are left with the two remaining 2 atoms, phosphorus and oxygen. Now we compare the electronegativity of these 2 atoms, and we know that the electronegativity of atoms increases from left to right in the periodic table, and that is why oxygen is more electronegative than phosphorus atom. Here phosphorus is taken as a central atom, being the less electronegative atom in comparison to oxygen. Now the final step is to draw the skeleton structure. Well, in this step we connect the remaining atoms to the central atom, that is phosphorus. Let me draw here phosphorus atom. And remember, if a compound has hydrogen and oxygen atoms, we make possible pair of hydroxyl group. You can see that there are 3 hydrogen atoms and 4 oxygen atoms. 3 pairs of hydroxyl group can be made, and we connect these hydroxyl groups directly to the central atom. Here we have these hydroxyl group connected to central atom. This is the easiest way to arrange the remaining atoms around the central atom. Now still we are left with one more oxygen atom that is also connected to central atom, that is phosphorus. Now finally we satisfy the valency of these atoms. Let me take the central atom, that is phosphorus. Phosphorus has 5 valence electrons, and here you can see that phosphorus is forming 4 bonds. It means that it has used 4 out of 5 valence electrons in forming 4 bonds. To satisfy its valency, it forms double bond with this oxygen atom. Now the valency of phosphorus atom is satisfied. Now let me take this oxygen atom. It is forming double bond. and the oxygen atom has a 6 valence electron, and this oxygen atom has formed double bonds by using its 2 electron out of 6. It means that it is left with 4 valence electron, and we show these 4 valence electron in form of dots. These are the electrons which do not take part in the bond formation. And if you look at the remaining these 3 oxygen atoms, you can see that each oxygen atom is also forming 2 bonds, and here each oxygen atom also has used 2 valence electrons out of 6. That is why here every oxygen atom is left with 4 valence electron in this diagram. And well, the pair of dots is considered as a lone pair electrons, and so here we can say that since each oxygen atom is shown with 2 pairs of dots, it means that each oxygen atom is having 2 lone pair electrons. Now, to check whether this diagram satisfies the total valency of electrons of phosphoric acid, we calculate the total number of electrons shown in this diagram. Well, here there are 4 oxygen atoms, and each oxygen atom is shown with 4 dots. It means that 4 electrons, 4 4 are 16. Now we calculate the number of electrons present in bonds. 1 2 3 4 5 6 7 8. There are 8 bonds, and each bond has 2 electrons. 8 2 are 16. Now you can add these numbers up. 16 plus 16 is equal to 32. Well, you can see that it satisfies the total valency of electrons of phosphoric acid. This is the Lewis structure of phosphoric acid. Let me take one more compound, that is sulfuric acid, and its chemical formula is H2SO4. To draw its Lewis structure, we follow the same step. First step is to calculate the total number of valence electron. Hydrogen, obviously it has 1 valence electron, and since there are 2 hydrogen atoms, we multiply by 2. Here we have 2 hydrogen atoms have 2 valence electron. Next atom is a sulfur atom. It is present in 6th group, that is why it has 6 valence electron. And next is oxygen atom. Oxygen is also present in 6th group, that is why it has 6 valence electrons. Since there are 4 oxygen atoms in sulfuric acid, we multiply by 4. 6 4 are 24. Well, 4 oxygen atoms have 24 valence electrons. Now we add these numbers up. 6 plus 2 is equal to 8, and 8 plus 24 is equal to 32. The total number of valence electron in sulfuric acid are 32. Now we follow the second step, that is to select the central atom. Well, as we know that central atom is selected that atom which has the lowest electronegativity except hydrogen atom. We cancel hydrogen atom as a part of selection of central atom, and so we are left with 2 different atoms, that is sulfur and oxygen. And if you compare the electronegativity of these 2 atoms, oxygen is more electronegative than sulfur atom. Here sulfur atom, being less electronegative, is selected as a central atom. Now the final step is to draw the skeleton structure in which we connect the remaining atoms to the central atom, that is sulfur. Let me write here sulfur, and remember, as I previously stated, that if a compound is having hydrogen and oxygen atoms, we make the possible pair of hydroxyl group. There are 2 hydrogen atoms and 4 oxygen atoms. Then 2 pairs of hydroxyl group can be made, and these groups are directly connected to the central atom. Here we connect these groups. Now we are left with 2 more oxygen atoms, because 2 oxygen atoms are used in hydroxyl group in connecting to the central atom, and so these remaining 2 oxygen atoms are connected to the central atom also. Finally, we satisfy the valency of these atoms. Let me take the sulfur atom, that is the central atom. Sulfur has 6 valence electrons, and you can see that sulfur is forming 4 bonds. It means that it has used 4 out of 6 valence electrons, and to satisfy its valency, it forms a double bond with these 2 oxygen atom. It is formed. Now you can see that it is shown with 6 bonds. It means that its valency is satisfied. Now let me take oxygen atom. Each oxygen atom has a 6 valence electron, and say here this oxygen atom is forming double bonds, and these 2 oxygen atoms are forming 2 bonds, means number of bonds are same, and this oxygen atom is also forming double bonds. And in forming 2 bonds, each oxygen atom is using 2 out of 6 valence electrons. It means that each oxygen atom is left with 4 valence electrons, and these electrons are shown in the form of dots. These are the electrons which do not take part in the bond formation. Now to check whether this diagram satisfies the total valency of sulfuric acid, we calculate the total number of electrons. There are 4 oxygen atoms, and each oxygen atom has 4 dots, means 4 electrons. 4 4 ja 16. Now we calculate the number of electrons present in bonds. 1 2 3 4 5 6 7 8. There are 8 bonds, and each bond has 2 electrons. 8 2 ja 16, and we can add these numbers up. 16 plus 16 is equal to 32. You can see that it satisfies the valency of electrons of sulfuric acid. This is the Lewis structure of sulfuric acid.